Hi everyone, how are you? Are you stressed? Do you know what stress is in terms of physics? It's force per unit area. So, can you tell me in the comments below whether stress is a scalar or a vector? Okay, now let's jump to exercise 10.2. So the first question is you have to find the magnitude of a vector A, which is I cap plus j cap plus k cap. So take out the x, y and z components, and under root x square plus y square plus z square will give you the value of the magnitude, which is also known as the coefficient of I cap, j cap, k cap. Similarly for second one, B vector you have to calculate. So take out the coefficient. Coefficient will be 2, -7 and -3. Same for C. Next question, you have to write two different vectors that have the same magnitude. So what you can do, if suppose for A you have given 2i cap plus 10j cap plus 7k cap, just remember one thing, the magnitude will be same only when you have particular x, y, z same. Now you have to write two different vectors having same direction. So for same direction, the value of A should be equal to lambda b, where lambda can be any value of a scalar, for example 5, 6, 7. So it should lie along the same line. Next question, you have to find the value of x and y such that vector A and B are equal. So again compare the coefficients and that gives you x equals to y equals to 3. Now find the scalar and vector component of the vector with initial point 2, 1 and terminal point -5, 7. So first calculate AB. So AB will be B minus A. So you have to reduce the component of A from B. So it will be -5 minus 2 plus 7 minus 1. Next question, you have to find the sum of vector A, B and C. So add the x component together, y component together and z component together to get the solution. Next question, find the unit vector in the direction of vector A, which is I cap plus j cap plus 2k cap. So simply divide it with the magnitude of this vector. This will give you the direction of vector. And that is nothing, L, M and M. Now next question, find the unit vector in the direction of vector PQ. Similarly, take out PQ, which will be Q minus P. Reduce the components to derive PQ. And next, take out the unit vector along PQ. Simply divide it by the magnitude. Next question, find the unit vector in the direction of A plus B. So the first thing is calculate A plus B. Let's name it as C. And now what you have to do? Calculate the unit vector. Divide it by the magnitude. Next question, find a vector in the direction of vector 5i cap minus j cap plus 2k cap that has magnitude 8 units. So suppose here you have the vector A already given. Now the next vector that the question is asking you is to calculate, for example, let's say it as C. Next question, show that the vectors are collinear. So collinear means it should lie along the same line. If they lie on the same line, then the vector should be same. However, there should be some scalar component. For example, B can be lambda A and lambda can be any scalar. So let's see what is the relation between A and B. Clearly, we can see B is equal to -2A. So if A is plotted like this, then B will be in the opposite direction. Next question, find the direction cosines of A. So simply divide it by the magnitude. So first calculate A cap, which means the unit vector. And how do you calculate that? You divide the vector by its magnitude. Next, direction cosines are nothing but the respective coefficient of x, y, z. So coefficient of I cap, j cap, k cap here turns out to be 1 by root 14, 2 by root 14 and 3 by root 14. Now next question, calculate the direction cosines of line A to B. So see, here the line is A to B, which is AB. So what will you do? You will do B minus A. So minus 1 I cap plus minus 2 j cap plus 1. Since it is minus 3 on the A side, so minus minus turns out to be plus. So that is k cap. Now take out the magnitude of vector AB. Now take out the unit vector AB. And that gives you, see, the coefficient of I cap, j cap, k cap is what? LMN respectively. Next question, show vector A is equally inclined to the axis OX, OY, OZ. So take out the unit vector and see where they lie. So unit vector will give you LMN. What are LMN? Nothing but cos alpha, cos beta, cos gamma. As you can see, the value of cos alpha, cos beta, cos gamma is same, which is 1 by root 3. So if I tell you to calculate alpha, what will you write it as? Cos inverse 1 by root 3. Same you will write for beta, same you will write for gamma. So this proves that they are equally inclined to OX, OY and OZ. Next question, OP and OQ are given and you are given the ratio in which the vector OR divides PQ and the ratio is 2:1, and you already know the formula from the previous video. If you don't remember, please click the link in the description below to understand how this formula came. Now calculate R. Now another scenario is that the line is divided externally in the ratio 2:1. So nothing more, you'll just have one minus sign and 2 minus 1 in the denominator will give you 1. So your answer will be minus 3 I cap plus 3 k cap. Next question, you are given P and Q and the vector OR divides the line in the ratio 1:1. Why? Because this is the midpoint. So calculate R and you will have 3 I cap plus 2 j cap plus k cap. Next question, A, B and C are three vectors and you have to show that A, B, C are the vertices of a right angled triangle. So first calculate AB, then calculate BC and calculate CA. Now calculate the magnitude of AB, BC and CA. It's clear that BC square is equal to AB square plus CA square. Now next question. So you have to figure out whether the given statement is true or false. So AB plus BC plus CA equal to 0. So as you can see from the diagram, AB plus BC will be equal to AC. So AC, if we plot backward, will be minus CA. Now if CA is brought on the left hand side, this statement holds true. Next question, AB plus BC minus AC is equal to 0. Now AB plus BC is equal to AC, as we can see from the triangle law of vector addition. Next question, AB plus BC minus CA is equal to 0. AB plus BC will be equal to CA. But can AB plus BC equal to CA? No, it's false because AB plus BC is equal to AC. So next is AB minus CB plus CA is equal to 0, which will be equal to AB plus CA is equal to CB. So this will be true. Next is if A and B are collinear. So B will be equal to lambda A for some scalar. We already saw this in example before. So this is true. Next, A will be equal to plus minus B vector. This is also true. If suppose A is a line and then I plot it backward as minus A, will that not be a collinear? Obviously that will be a collinear. Next is the respective component of A and B are not proportional. So this is false. We already saw na. Next, both A and B have same direction but different magnitude. So this is not always the case, right? So this will also be false. Thank you for watching. Thank you for watching. If you like the video, please like, share and subscribe.